Hello. Today we're going to be going over square root and cube root graphs. So the first thing we're going to do is we're going to start off with functions that we know to help us get to our new functions. So we're going to start off with a quadratic function. Our vertex here is going to be 0, 0. Normally you're going to do your 1, 3, and your 5 pattern to graph this. And normally you would go on the left-hand side as well. However, our domain right here is being restricted to only the right half, all of the x values greater than 0. So looking at this, our graph would look like this. Our domain would be 0 to infinity with a range that is also 0 to infinity. If you're to make a table of values here, x and y, the ones that we graphed were 0, 1, 2, and 3, and when we squared them, we got 0, 1, 4, and 9. Now what we're going to do is we're going to take the inverse of the square root, or the square. So the inverse of x squared is the square root of x. So if we were to look at this, what we're going to do is we're going to graph our inverse function by taking our original function and we're going to switch our x and our y values. So the x values now are 0, 1, 4, and 9, and our y values are 0, 1, 2, and 3. If you'd like to think of it this way, 0, 1, 4, and 9 are nice numbers to square root, and the square root of those numbers is 0, 1, 2, and 3. So we can then graph those as coordinate points and see our picture of the square root of x. This is what y equals the square root of x should look like. It should look like a quadratic function turned sideways or reflected over the line y equals x based off of our talk with inverses. So the range of our original function now becomes the domain of our inverse function. And the domain of our original function becomes the range of our inverse function. And you can see visually that that is still the case here. So anytime you have to graph the square root of x, you need to have these table of values kind of memorized, because then what we're going to do is start moving them all around. We also are going to start graphing cube root functions, but that is not something that we have ever seen before. So we're going to start with something that we have seen before, which is x cubed. So what I'm going to go ahead and do is I'm just going to make up some numbers here, -2, -1, 0, 1, and 2. If I were to plug those in for x and cube them, I would get -8, -1, 0, 1, and 8. I then could graph this, so -2, -8, all of those different coordinate points. And I know my graph should end on the right side pointing up and on the left side pointing down because it is a cube function. This is the parent graph of x cubed. The domain for this one is -infinity to +infinity, and the range is also. So if we were to take and switch x and y and solve for y, our inverse function would be the cubed root of x. So to graph this, we don't know how to graph this. So what we're going to do is we're going to take our original function and we're going to take that table of values and we are going to switch x and y. So -8, -1, 0, 1, and 8 now become my x values. And -2, -1, 0, 1, and 2 now become my y values. So then I can graph each of these as a coordinate point, and I can kind of imagine flipping y equals x cubed over the line y equals x. This is what a cube root graph should look like. Somewhat similar to a square root graph, but it keeps going into the negatives because you can take the cubed root of a negative number, which means my domain here is going to be -infinity to +infinity, as is my range. So moving forward, when we graph these, we want to make sure we know this table of values for cubed roots, the -8, -1, 0, 1, and 8. And for square roots, we have to have the 0, 1, 4, 9 and the 0, 1, 2, 3 in our heads. Because now what we're going to do is we're going to start taking these and move them all around. So our A, H, and K are all going to do the same things that you would normally think. So the A is the vertical stretch and flip. H is going to be left and right. And K is going to be up and down. So in order to graph these, we need to figure out which ones are going to change X values and which ones are going to change Y values, because then we can actually move our table of values around using those important X values and Y values that we talked about earlier. So let's take a look at what we mean here. So first of all, for the transformations, X minus 5, that is going to move my graph right 5. The 1/4 out in front is going to be a vertical compression. And then the plus 3 is going to move my graph up 3. Normally, my table of values for a square root function is going to be 0, 1, 4, and 9 for my x's, because they're nice to square root, and 0, 1, 2, and 3, because that is the square root. But that was before we're moving them all around. So now we need to start actually moving them left, right, up, down, and stretching them. So anything that is inside with the x is going to impact your x. So the right 5 is going to occur to your x values. So you're going to go ahead and add 5 of those to move it right 5. In essence, any h value is always going to change your x values. So if I were to take 0 and move it right 5, I'd get 5. 1 moved right 5 is 6. 4 moved right 5 is 9. And finally, 9 moved right 5 is 14. Then anything outside, not really with your x's, is going to deal with your y's. So that's the times 1/4 and then the up 3. So for your y values, to figure out your new ones, you're always going to multiply by your a value and then add your k value. You're following your order of operations. So for this one, you're going to take all of your outputs and you're going to multiply by 1/4 and then add 3. So 0 times 1/4 plus 3 is 3. 1 times 1/4 plus 3 is 3 1/4. 2 times 1/4 plus 3 becomes 3 1/2. And 3 times 1/4 plus 3 is 3 3/4. These new ones, whatever you get on the inside, this is your new table of values. So your first point is 5, 3, then 6, 3 1/4, and then 9, 3 1/2, and then 14 is way over here. This is what our new graph looks like. So visually, looking at this, compare it to what your normal square root graph would look like. It should be moved right 5, up 3, and then squished by a factor of 1/4. And so that's why it looks kind of so narrow there. So it worked out. Now your domain, it should be always dealing with your h value. For this one, we moved it right 5. So my domain starts at 5 to infinity. My range deals with my k value. For this one, I start at 3 and it's pointing, the arrow's going up, so it's 3 to infinity. So any square root function, you're going to do the same type of thing. You're going to do 0, 1 for 9 and 0, 1, 2, 3 down the side. You're going to do h to the 0, 1 for 9, and then the times a k to the 0, 1, 2, 3. The only difference with cubed root is the numbers on the side. So let's take a look at this. When you see a problem like this, always pay attention to the number on the outside there. That is telling you this is the cubed root, and that is telling you the -8, -1, 0, 1, and 8, and the -2, -1, 0, 1, and 2. For your transformations here, you're going to be moving left 6. You're going to reflect over your x-axis, and you're also going to move down 5. So the thing that deals with the x is the h value, so you're always going to add h. So h in this case is -6 to move left 6. So we get -14, -7, -6, -5, and 2. To your y values, you're always going to multiply by a and then add k. So for these ones, you're going to multiply by -1 and then subtract 5. So if you want to write out each of these, then you can. Otherwise, you can start just doing them in your head. So -2 times -1 minus 5 is -3. -1 times -1 minus 5 should be -4. 0 times -1 minus 5 is -5. 1 times -1 minus 5 is -6, and then -7 after that. So now all that's left is to graph your points. Now -14, -3 is off your graph grid, but the rest we could make. So -7, -4, -6, -5, -5, -6, and 2, -7. And then you're going to connect these and try to make it as much like that cube root function as you can. And the nice thing about cube root is that all of your domains and ranges are going to be -infinity to +infinity. So let's go ahead and try number 3. What I would like you to do is write down your transformations and then try your table and then come back to the video to see if you got it right. Okay, let's see our table here. You should have -11, -4, -3, -2, and 5 for your x values. Your y values then would be -3, -1, 1, 3, and 5. So if we were to then go ahead and graph those, we would then get the picture of what this cube root function that is moved left 3, stretched vertically by 2, and moved up 1 would look like. Your domain being -infinity to +infinity, as would your range. So looking at numbers 4 and 5, it's just kind of asking what are the transformations that are occurring for these ones. So for g of x, you have a vertical stretch of 2. You have a reflection over the x-axis, and you have up 14. Think about your cube root graph. That's what you would try to graph and move it all around. For the next one, it's a square root graph. This here would move it left 5 and have a vertical compression of 1/3. And finally, I want you to take a moment here to read number 6 and kind of make sense of what's happening with it. This is our first one where we are directed to our graphing calculator. So if we were to graph this, we would get y equals 62.5 cubed root of t plus 75.8. So with that, your graph should look like this, but you're going to have to change your window so that you can see all of your different values if you'd like to look at the graph. We are asked to figure out the age of the elephant whose shoulder height is 200 centimeters. So for this one, the 200 centimeters is your shoulder height. So if you were to type in another equation here, 200 would be your y value. So you're going to have to do second calculate and figure out where those intersect. So you can go ahead and do that, and you can try to figure out exactly where that would be. When you do that, you should get this answer 7.85 years for your x value for a height of 200. Now, the next one is asking you somewhat similar question, except for 9 here is your t. So you can plug 9 in for your t. You could look at your table and figure out when x is 9, what is y. And you should have 205.81 centimeters when you check out your table there. So thank you very much for listening. Please let me know if you have any questions on anything. Thanks.